In this problem, we have a bucket that is being lowered by a rope that has a given amount of tension in the rope. We've been asked to find the acceleration of the bucket. Now, since this is a problem that involves forces, let's start by drawing a force diagram for the bucket. So here's our bucket, and here is the handle. And there are going to be two forces acting on the bucket. First, there is the force from gravity, so the weight of the bucket, pulling downwards, with a magnitude of mass multiplied by the gravitational acceleration. There's also the upward force pulling upward on the bucket from the tension in the rope. This is the value that's given to us in the problem as 163 newtons. Now, based on what we've been told in the problem, those are the only two forces that we know are acting on the bucket. So the next step is to apply Newton's second law, which states that the net force acting on an object is equal to the object's mass multiplied by its acceleration. This is equal to the sum of the forces acting on the bucket, on the object. So MA is going to be equal to the sum of the forces acting on the bucket. Now, first off, that involves the tension, which is pointed upwards, and then pointed downwards in the opposite direction, so opposing the force due to tension is the weight of the bucket, mg. So we're going to have to subtract because the forces are working against each other. So minus mg. Now, the purpose of our problem is to solve for acceleration a, so we need to take this equation and algebraically rewrite it to solve for acceleration. And we can do this pretty simply by dividing both sides of the equation by mass to get a on its own. So a is equal to the tension minus mg divided by the mass, m. So this is the equation we'll use to solve this problem. So all that's left for us to do is plug our values into a calculator. So acceleration is equal to tension, which was given in the problem as 163 newtons, minus the mass of the bucket, 14 kilograms, multiplied by g, so acceleration due to gravity, which has a typical value of 9.8 meters per second squared. And then we divide all of this by the mass of the bucket, which is once again 14 kilograms. If we put this into a calculator, then we get a value for the magnitude of the acceleration as 1.8 meters per second squared. And that is the magnitude of the acceleration. Note also that this is a positive value, which, because we were using upwards equals positive earlier on when we were writing out Newton's second law, this means that if the acceleration is positive, then the bucket is accelerating upwards. So the direction of the bucket's acceleration is upward. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a question or request, leave a comment down below, and I'll do my best to help you out. Bye-bye.